I'd like you to notice the size of the TIFF. It's about 12 meg. So after this conversion, let's see the same image but in map format. It's 16. So the size increases when you use the map. If I change this map format to, let's call it TIFF, and go to Maya, it will read it. It will still read it, even though it's a map format and we changed the name from map to TIFF. It can still pick it up and read it. So how that helps is if you already set up your environment, set up everything, and you don't want to go back and re-pick the file, you can just rename the file from the outside, from the Explorer window, and Maya will still pick it up and read it. So let's render this image and see if there's any difference. So here's the render. Let's compare it to the previous one. Here we go. There's no difference in the image, but there is difference in the render time. Even though it increased, that time will change when I go to my final render. Usually all my renders I do it from the command line. It will be very, very efficient to have the map format or a memory map file. So far for the displacement, this is pretty much what I'm looking for. Now I'm just going to go ahead and start adjusting the material to get it closer to what we have in Mudbox, just because I want to compare the two images from Maya and the Mudbox image that I captured, just to see if I can get as close as possible to that in Maya. So here's the Maya render. Bring the image that we had as a screen capture from Mudbox. And let's make a quick comparison. There's obviously change in size, but let's have a quick look here in this area. I'd say it's holding the details. So that's it pretty much for the adjustment of the approximation node and the displacement map. But the last thing I'm going to do is adding a subsurface scattering shader on that creature, simply because we're going to simulate skin, and I'll explain why did we use an accurate measurements or a real world measurements for that head before we started. I'm going to go to my hyper shade, and in the mental ray section I'm going to grab under the material, and I'm just going to get the MIS fast. Also I need a map, light map actually. This is my shader, the one that we just assigned to the object. If I go to the SG node under the mental ray section, you'll have a material slot. You can just middle mouse drag and drop. Also for the SS shader, there is lots of documents and tutorials on the web, so I'm just going to set it really quickly here. I need a map file or an actual physical file that sits on my hard disk. It has to be 32-bit, and I'm going to make sure it's rewritable because I'm going to reuse it again. I think I grabbed the wrong node here, sorry. Here we go. So a quick look at the connection. This is the displacement map, the skin shader, and the light map. So if we render this as is, so here's the result. I'm using the default attributes from the SSS shader, and we get a nice scattering for simulating the skin on the creature. And that's one of the important things that I like to put in mind when I'm modeling, that I try to make it as accurate or as close as possible to world measurement, just because the SS shader, subsurface scattering shader, and the mentor ray, they take that in consideration. However, if you have your object, let's say the object scale now is 1. If it was 0.1 and you want to fix that, you'll definitely, if you render it, you'll get a different result. Or how to correct that behavior in mentor ray, you will have to go to the subsurface scattering under the algorithm control. So if my object was 0.1% of that, I will have to multiply here by 10. In other words, the scale conversion works that way, that what is the percentage or what is the value that I need to multiply in here to correct the model size in real world. So the model size was 0.1. If I changed it, in order to fix that behavior, I will need to multiply here by 10. And if it was 10, I need to divide by 10, so it will be 0.1 here. I hope that makes sense. So I'm just going to do one last render from the perspective view. I'm just going to put new material here. So here's the final render. I assigned DGS shader on the eyes before I render, and I just made them black, so it gave me a nice eye there really quickly, really fast. One thing I noticed now after using the subsurface scattering is the details on skin has kind of washed out because of the scattering. What I can do to bring it is to go to the shader itself, under the bump. Let me bring the hypershade. The trick that you need to remember when working with the subsurface scattering is that when you use a bump, you need a bump node, an actual bump node that you have in Maya. And just set the value, grab your file. Keep this image and render one more time. So here's the render done with the bump map. You'll see there is a difference between the previous render and this one. That's it pretty much for this session. Tweaking the SS shader is a complete session by itself, and I believe it was already covered in multiple sites. So we already talked about how to prepare the model to take it to Mudbox, how to check the triangles and quads and insides. Exported the model as OBJ, brought it to Mudbox, divided it in different levels, used different brushes and strokes, and then exporting the displacement map, bringing it to Maya, bringing the object as OBJ as well, and doing the final displacement and even added subsurface scattering. I hope you enjoyed this session. So till the next session, happy rendering.